So in this circuit, we are going to use this magnet to turn this probe on, which will in turn power this LED, which is this is an optically isolated switch. And the reason I'm using that is if I use this output directly in the, for the relay, it sinks too much current and the circuit won't work. It short circuits the sensor. So I have the power turned on and this changes the flux density. So if I press B, you see how this number changes. So it increases. See how that's changing? And you'll notice that, so right now, uh, this circuit is not conducting. So that's why this is on coming through here. Because if it was conducting, it will conduct to ground like this. So because that's conducting, this LED is conducting, which turns this relay on. Well, yeah, it turns relay on, and this is the normally closed contacts, and they have opened, and the normally open contacts have closed, and this LED is on. So I'm going to start increasing the flux density. Okay, it's going to work. I know it has worked. There we go. So about 205 Webers or Teslas, I guess it's the units. This this device is conducting in this direction. Therefore, there is this LED, this probe is off, and this shuts off this LED, which turns this transistor off, which turns this relay off, and the normally closed contacts will it'll go back to its original condition. This LED comes on, this LED goes off. I put the switch here because right now you can see that it's actually not doing anything, because initially when I built this circuit, I did not have this opto isolator and I was getting all kinds of problems. And I was trying to figure out what to do, and I put this switch in here just to get that working. So in this particular situation, it's actually redundant. Now to reduce the flux, the letter B increases it, that shift B will decrease it. So here it's shut off, but this did not change right here. The relay did not move. The contacts didn't change positions because this switch is off. So let me just put the switch back on. Kind of an interesting circuit there. This particular device, it's found under magnetic flux devices. And if you go to sources, it's signal, current sources, magnetic flux. That's where you find this device. Let's see what else would. This one is the optical isolator. We just go. Well, it's called optocoupler. Optocoupler, opto-isolator. I use those terms interchangeably, and that's the optocoupler that I used. Almost any of these would have worked. This one I find to be kind of easy to use. This relay is this one under basic rated virtual, normally open, normally closed, relay rated. That's the relay that I used. And I just artificially changed this power supply because I don't want to put all those current emitting resistors and all that stuff. That just complicates the circuit. This keeps it really nice and simple. I changed these voltages a little bit to 24 volts standard industrial voltage. Also, if you go much less than that, this thing won't turn on. I guess I could have changed these and put this to a different voltage. But VCC, if I change this, let's see, if I change this also changes. So I guess I could have put another power supply. I was just trying to make this circuit as simple as possible.